This is parabola notes. It says a parabola is a set of all points for which the distance to a fixed point and your fixed point is your focus, and a fixed line, this is new, and your fixed line is called a directrix. That distance is going to be the same. So down here on your pictures, I'm going to show you that this right here is your focus. This right here is called the directrix. This is going to be your vertex. So this distance right here and right here is going to be exactly the same. I'll go ahead and put it over here as well. This is your focus. This is your vertex. This line right here is called your directrix. And so this distance and this distance is going to be exactly the same. It says for all parabolas, you still have a vertex called HK. So it's no longer called a center. It says you have the absolute value of P, and it says this is your distance, which I just talked about this. This is your distance from your vertex to your focus. So your distance from your vertex to your focus, that from here to here, from your focus to your vertex, was the same as from your vertex to your directrix. Those are equal. I'm also now going to tell you that this is P. So they're not only the same, but they are called P. Okay, it says the focal chord of a parabola is, this is the width of the parabola, and this is through the focus. So this is how far the parabola is, but I'm going to go through the focus. So I'm going to go right through here. Okay, and this right here is called your focal chord. I know I'm giving you lots of information right now. So I'm going to go right through here, and that right there is called your focal chord. Okay, in order to find this, the length, you're going to do the absolute value of 4 times P. Now every time I'm doing the absolute value, I'm saying that because you can't have a length or a distance that is negative. So that will always be positive. On a vertical parabola, this is going to kind of be your norm. This is going to be y equals, you have an a value, and this is x minus your center, so minus h quantity squared, plus your k is on the outside. Remember, I have a center, which is hk. The difference in your horizontal looks a little bit different. You're going to have x equals, you still have an a on the outside. Basically, your a tells you how skinny, how fat, and then if it's facing up or facing down. Your a value, this is going to be y minus k quantity squared, and then your h is on the outside. And if you notice, you have a plus here. And then your normal goes to the right, your negative will go to the left. Your normal's up, your negative goes down. Okay, so if your center is right here, or your vertex, your axis of symmetry, of course, is going to cut it right in the middle. So your axis of symmetry, I'm going to call it the AOS, goes right through the middle, and that is on both of them. Your axis of symmetry is right in the middle. Well, my axis of symmetry on this one, I like to think of it as an x equals. So if it's an x equals and it goes through my vertex, then that means it's going to be x equals the h value because I'm going right through the middle. Okay, and that's my x value. In order to get my focus, I'm going to have to rise up this way. So that's not going to change my x values, that's going to change my y values. And it's going to change it a value of P. So this is how I'd figure that out. My H stays. I'm going to take and add my P to my Y value, which is my K, in order to get my focus. Again, you do not have to memorize this. I'm showing you how I'm getting it. In order to get my directrix, remember that's a distance of P, I would go down to get my directrix. So this is a line. So I'm going to take my y value, which is k, and I'm going to take away the distance of my p. Okay, I'm going to do the same thing on my horizontal. I have an HK, which is my center, so everything stems from my center. In order to get my axis of symmetry, it cuts right through my vertex. And since it's a line that's going horizontal, that means it's going to be a y equals. So what does y equal here? It equals k. In order to get the focus, I'm going to go to the right, so that's going to change my x values, and I'm going to add this distance right here. So that means I'm going to take my x value and I'm going to add my p, and my y value stays. In order to get my directrix, I'm going to decrease it, so I'm going to go to the left p values. And remember, directrix is a line, so in this case it's going to be an x equals, and I'm going to decrease this x value, so that means it's going to be h minus p. Okay, so let's try this first problem. This right here is written in standard form, and because it is x equals, it's horizontal. I'm also looking at this right here. Because it's negative, I know that it's going to face to the left. It's going to be opposite. So I'm going to just kind of sketch it so I know what I'm doing. Okay, since it's x equals, this right here, these are opposite. So this is going to be 1, negative 2. And I'm going to sketch as I go just to kind of help you out. So 1, negative 2. This is vertex. Label the graph as you go. That means since it opens this way, my focus is in the middle and your directrix is going to be over here. What I do know is that my axis of symmetry is going to cut through it. So you can go ahead and label that your axis of symmetry. And so since it's cutting through your y, that's going to be a y equals negative 2. Okay, so I don't know my focus directrix or focal chord. So I'm going to take this. I should have put it at the top. I know this is my a value. A is negative 1 over 8. So a is equal to 1 over 4p. So if a is equal to 1 over 4p, and if I fill this in, negative 1/8 is equal to 1 over 4p. What does p have to equal? I'm going to cross multiply and get 4p. Negative 4p equals 8. Therefore, p is equal to negative 2. Now remember, p is your distance from your focus to each direction. So if I go 2 this way and I'm thinking absolute value, and 2 this way, I get my focus and my directrix. Because I know it opens to the left, this is my focus, and this is my directrix, and I'm going to go ahead and draw it as a line, because this is my directrix. Okay, so focus would be negative 1, negative 2. My directrix is an equation, and it's x equals, so x equals 3. Your focal chord. Remember your focal chord, if you look back up at the top, in order to get this, you take the absolute value of 4 times p. So if I look down here, this is going to be a length of 8. That means the entire length is 8, and it cuts through your focus. So I'm going to go 4 each way. So 1, 2, 3, 4, and 1, 2, 3, 4. So this basically tells me how fat my parabola is. So I'm going to go from my vertex and cut through, from your vertex and cut through, and there's your answer. All right, let's try another. Okay, on this one, it says find the standard equation of the parabola, and it says how do you know it's a parabola? So like, how do you know it's not an ellipse or hyperbola? I know it's a parabola because I only have one y. There's not a y squared, like it's just plain Jane. So since it's just plain Jane y, I'm going to solve for that. So 2y, I'm going to move everything else to the other side. that means it's going to be a y squared equation. So like x squared. So y equals x squared equation. And since it's going to be like that, I know it's a vertical. All right, so 2y equals moving everything over and completing the square. I'm just going to kind of set it up right now. So this is what it looks like putting y by itself. So 2y equals, factor out your negative 1/2 because you cannot have the coefficient. If I take out a negative 1/2 from negative 1, this gives me a positive 2x. I'm going to leave a blank to complete the square. And then I'm going to leave a blank to add this right here. If I complete the square, so half box square this is going to be a plus 1. This is really negative 1/2. Because I'm on the same side of the equal sign, I'm going to add a 1/2. So 2y is equal to negative 1/2 x plus 1 quantity squared. This right here is going to give me a minus 6. Because I'm solving for y equals, I'm going to divide everything by 2. So y equals, divide negative 1/2 by 2, that's negative 1/4 x plus 1 quantity squared, and this divided by 2 gives me a 3. Okay, this is my standard equation. So now you can graph your vertex. This would be negative 1, negative 3. Negative 1, negative 3 is your vertex. Therefore, you know your axis of symmetry is going to go right through it because it's vertical. So x is equal to negative 1. My focus and directrix in focal chord. We now need to look at the formula I gave you. If I know a is equal to negative 1/4, then I'm going to set that equal to, do you remember this? A is equal to 1 over 4p. So negative 1/4 is equal to 1 over 4p. So p is equal to negative 1. That means if I go up 1 to be vertical and down 1, this up here is going to be my directrix. And how do I know this is directrix instead of my focus? I know this is directrix because this right here tells me, this negative tells me it's going to be facing down. This right here is my focus. So my focus is negative 1, negative 4. My directrix is y equals negative 2. The last thing I need to do is find my focal chord length. And your focal chord length is absolute value of 4 times p. So 4 times negative 1 is just 4. So out from this, 2 to the left, 2 to the right. The whole length of the chord needs to be 4. Okay, let's triangle backwards. I have a focus of 1, negative 2, and a directrix of y equals negative 1. That means it cuts through your y-axis of negative 1. If this is your directrix and this is your focus, that means your vertex is going to be right here. So it's going to look somewhat like this. But my vertex is here and your P is really little. So it looks like my P is a half. So I'm going to take my formula. A equals 1 over 4 times P, which is a half. So if I take a half of 4, then my A is equal to 1 over 2. Now I know that it's facing down, so that is going to be negative. And we know this, because it's facing down, that I know it's going to be a y equals. I know my A is negative 1/2. My vertex, I can figure out right here, is going to be 1, I'm going to just say negative 1.5 because it's in the middle of both of these. So this is going to say x minus 1 quantity squared, then minus 1.5. And I didn't worry about my focal chord because I really didn't have to worry about graphing it. Okay, on the last one, with a vertex of 3, 6, and it contains a point 4, 4. It has a horizontal. Okay, so we've got an axis of symmetry this way. If it's got a horizontal axis of symmetry, then I know it's going to be an x equals. And I'm just going to write out this equation really quick. Okay, let's fill in our vertex. Remember, this is backwards here, so this is going to be y minus 6 quantity squared, and this is going to be plus 3. Now, the bad thing about this is that we don't have our a, but we do have this point. So I'm going to plug this in. So 4 is equal to a, and then 4 minus 6 quantity squared plus 3. So it looks like we're going to have to solve this in order to get our a. So 4 minus 6 quantity squared, that's going to be 4. Move your 3 over, so a is going to be equal to 1/4. Therefore, looks like we have our equation. X is equal to 1/4 y minus 6 quantity squared plus 3.